Hi everyone, Miss Robin here. So happy to be with you for a fun session of fraction learning. Today I need your help to figure out how much soil I need to buy for the box planters in my garden. Each one is a different size and requires a different amount of soil. The first planter I need to fill requires 1 5/6 bag of soil. The second requires 2 2/3 bag of soil to fill. The third requires 1 5/12 bag, and the last planter requires 2 5/6 bags of soil. How am I going to figure out how many bags of soil I need to buy? Great idea. Let's add them all together. So 1 5/6 plus 2 2/3 plus 1 5/12 plus 2 5/6. Uh-oh. Does anyone see the problem here? Exactly. These denominators are not the same. We are going to need to find equivalent fractions for some of these so we can add them, because as you know, you can't add pieces that aren't the same size together. 1/3 plus 1/4 can't be done unless you find a common denominator and make equivalent fractions. Before we begin the actual calculations to find out how many bags of soil I need, let's estimate an answer so we will have an idea if our calculated answer is reasonable or not. We need to estimate each fraction and then add the estimates using mental math. So we have 1 5/6, which is close to 2, and 2 2/3, which is close to 3. 1 5/12 is closer to 1 than 2, and 2 5/6 is closer to 3. So let's see, 2 plus 3 plus 1 plus 3. So I estimate that I will need 9 bags of soil. Okay, how do we find equivalent fractions with unlike denominators? Great idea. I heard someone say we can make area models. I like that idea. Let's try it out. Let's pick 2 of the fractions to add together first. 1 5/6 and 2 2/3. If we're going to draw an area model for these 2 fractions, they would look like this. Now we can see that 6ths are smaller and 5/6 can't be simplified. But I can make the thirds into 6ths and find an equivalent fraction with the same denominator. So let's see. Each third will need to be divided into how many pieces? 2, perfect. Now we have 1 5/6 plus 2 4/6. What's the sum of 1 5/6 and 2 4/6? 3 9/6. We can see that 9/6 is a fraction greater than 1. And if I draw that out, we would have 1 3/6. So the actual sum is 4 3/6. I can see that one of the other planters requires 2 5/6 bags of soil. And since I already have 4 3/6, let's add these together. What is the sum of 2 5/6 and 4 3/6? 6 8/6. Nice work, explorers. Again, 8/6 is a fraction greater than 1. But I know that 6 pieces makes a whole, and that would leave 2 remaining. So 8/6 is equivalent to 1 2/6. And when I add that to 6, we get 7 2/6. I am going to need a lot of soil for these planters. Okay, the last one requires 1 5/12 bags of soil. Again, we have fractions whose denominators do not match. 7 2/6 plus 1 5/12. Let's draw another area model to help us find the equivalent fractions. I just noticed something. When I made the 6th into 12ths, it was the same as me multiplying the numerator and denominator by 2. Cool. As long as I multiply both the numerator and denominator by the same number, in this case 2 halves, it will give me an equivalent fraction, because 2 halves is a different way to say 1 whole. And we know when we multiply by 1, the value of the number being multiplied doesn't change. So now back to adding these together so I will know how much soil to buy. We have 7 4/12 plus 1 5/12. And the answer is, yes, 8 9/12. Well, I can't buy 9/12 of a bag of soil, so I guess I'll have to buy 9 bags. Hey, look at that. That's the same as our estimate. Guess our answer is reasonable. Let's use this same thinking to solve another problem. Emily and Patrick shared a pizza. Emily ate 3/8 of the pizza, and Patrick ate 1/2 of the pizza. How much pizza do they have left over? What is this problem asking us? Exactly. We need to find out how much pizza is left after Emily and Patrick shared it. What do we need to do first? Yes, find out how much pizza they ate altogether. So let's see. Emily ate 3/8 of the pizza and Patrick ate 1/2. Well, these fractions do not have the same denominator, so we will have to find a common denominator so we can add them. I know that 1/2 is an easy fraction to work with, so let's see if we can change its denominator to 8s. I know that I can multiply any number by 1 and it will not change in value. So what do I need to multiply 2 by to get 8? Righto, 4. So if I multiply 1/2 by 4/4, I will get 4/8. Great. Now we can add up how much pizza they ate. So 3/8 for Emily plus the 4/8 that Patrick ate gives us a total of 7/8 of a pizza eaten. Nice work. Oh, wait. The question wants to know how much pizza was left over. Guess we need to subtract what was eaten from what is left over. So a whole pizza is 1, but I can't subtract 1 from 1, so we will need to make that a fraction with what as the denominator? Yes, 8. Since we know that they ate 7/8 of the pizza, we will use 8/8 to represent 1 whole. And just like with adding, we will subtract the numerators and keep the denominator, because its job is to tell us how many pieces make a whole. So let's see. 8/8 minus 7/8 is 1/8. They had 1/8 of a pizza left over. Okay, let's try another one. Lola, Jed, and Lucy want to collect 3.5 pounds of peaches so that their grandma can make cobbler. Lola has collected 5/6 of a pound. Jed has collected 10/12 of a pound, and Lucy has collected 3/4 of a pound. How many more pounds of peaches do they need to collect? Okay, explorers, what is this problem asking us to find out? Great. How many more pounds of peaches Lola, Jed, and Lucy need to collect? So first we need to find out how many pounds they already have by adding what they have collected so far. Let's add Lola's 5/6 of a pound to Jed's 10/12 of a pound. Using what we know about making equivalent fractions by multiplying a fraction by an equivalent of 1, what will we need to multiply 5/6 by to get an equivalent fraction with 12ths in the denominator? Fantastic, 2/2. So 5/6 times 2/2 will be 10/12. Wow, they collected the same amount of peaches. Now 10/12 plus 10/12 is 20/12. We can see this is a fraction greater than 1. So let's make it a mixed number. If 12 pieces make a whole and we have 20 of them, we have 1 whole and 8/12. Now let's add the 8/12 to the peaches Lucy collected. Lucy collected 3/4 of a pound of peaches. Using the same strategy of multiplying an equivalent of 1, what does 3/4 need to be multiplied by? 3/3, exactly. So 3/4 times 3/3 would be 9/12. Now 9/12 plus 8/12 is 17/12. Again, we have a fraction greater than 1, so let's make it a mixed number. 12 make a whole, and we have 17, so that would be 1 whole and 5/12. Great. So in total, we have 1 and 5/12 plus the 1 whole from the first sum, and that's 2 and 5/12 pounds of peaches. Now, the problem asks how many more pounds they need to collect. Guess we have to subtract again. 3 and 1/2 is the total they need, and they have 2 and 5/12. How are we going to subtract this? Interesting thoughts, explorers. Let's see. 3 is larger than 2, so we can subtract that. But is 1/2 greater than 5/12? You are correct, it is. Since half of 12 is 6, 6/12 would be equivalent to half. And we have less than that, so we can subtract the whole numbers and the fractions separately. 3 minus 2 is 1. Uh-oh, these denominators are not the same. Can we make halves into 12ths? Absolutely. If we multiply 1/2 by 6/6, we will get 6/12. And then we can subtract 5/12, and the answer is 1/12. So Lola, Jed, and Lucy need to collect 1 1/12 pounds more peaches before their grandma can make that cobbler. Our time is almost up for today, so let's review what we learned. When you are adding and subtracting fractions, the denominators have to be the same, and we can find equivalent fractions by multiplying fractions by fractions that represent the value of 1. Great work today, explorers. Thanks for tuning in. Bye.